This video is about deductive reasoning. Deductive reasoning, according to the book, is the process of proving a specific conclusion from one or more general statements. So what does this mean for us? Well, for us this means that we are using facts that we've learned or facts that we know to come up with a conclusion. We also might use deductive reasoning in things like logic puzzles or in decisions that we make every day. So we're going to look at a couple of vocabulary terms. The first one is theorem. A theorem is a conclusion that is proved to be true by deductive reasoning. Basically, that's a long way of saying that we've proven something's true by the reasoning that we're using. So the most famous theorem is the Pythagorean theorem, and that is the thing that I'm sure everyone has heard: a squared plus b squared equals c squared, or in this case they pictured h squared, but they mean the same thing as c squared. And how do you use this in your future? Well, there's lots of different ways. If we're trying to find out the height of something that's too tall for us to measure on our own, we can use the Pythagorean theorem. If we're trying to find how far something has traveled up in the air, we're able to use the Pythagorean theorem. And I actually heard about it being used once for that exact purpose of having kids measure how high their rockets are launching. You also might use it when you're creating a garden. If you're creating a triangular garden, or even if you're creating a rectangular garden, you're trying to figure out how much is half. There's all sorts of different ways that we can use the Pythagorean theorem in our real lives, and we will look more into these as we explore triangles more later on in the semester. So what is a variable? Well, a variable is a letter that's used to represent any number in a collection of numbers. So basically, anytime you see a letter in an equation or in mathematics, it's a variable. And it's there to say that we don't know the number that fits there yet, or it can also be used to say that there are a variety of numbers that can fit in this one spot. So here are some examples. In this case, we're looking for x, or the variable, to be a specific number. Here we're also looking for a specific number, and a specific number, and a specific number. When you see something like this where you have no answer off to the side, that's because we're looking more at a model than an equation, and we'll look at that in more detail later on in the semester as well. So here are some deductive reasoning examples. You'll see this one many times in the book, where you'll have select a number, multiply the number by a number, add a number to the product, which is the answer to a multiplication problem. Divide the sum by 2. Sum is the answer to an addition problem. Subtract 3 from the quotient. Quotient is the answer to a division problem. Then you also might see the term difference, which is an answer to a subtraction problem. So all of these are terms that you might see in problems such as this, and thus we're using our deductive reasoning skills to find the answers. You also might see something like a general statement. The employee to the buying manager: we need more hot chocolate. We can reason that hot chocolate is popular during winter months. It is winter, therefore we are running out of hot chocolate. For inductive reasoning, when we're looking at inductive versus deductive reasoning, you can have an example of: I threw a ball off the roof and it fell down. I threw a television off the roof and it fell down. I threw an apple off the roof and it fell down. Therefore, based on these observations, I'm going to reason that everything I throw off the roof will fall down. We know that this can be proven true because proven false, because what if I throw a balloon filled with helium off the roof? Is it going to fall down? Nope, it's going to float away. So in inductive reasoning, I'm using my observations to come up with a conjecture. It's inductive reasoning whether the conjecture is proven true or proven false. For deductive reasoning, gravity causes things to fall downwards. Falling downwards causes things to get damaged. Therefore, gravity causes things to get damaged. I'm making a conjecture, or I'm making my conjecture off of these two statements, and this will most likely become a theorem because gravity can cause things to get damaged. If you have any further questions about inductive or deductive reasoning, please feel free to contact me anytime.